Hello there. Welcome back to another dive into the fascinating world of human evolution. Some love to tease redheads for their fiery locks. Others adore them, calling them rare gems in a sea of dark-haired hues. And then there are those who cling to the sensational myth that redheads are on the brink of extinction. Let's set the record straight. While red hair comes from a recessive gene, recessive doesn't mean doomed. Even if no redheads were born for generations, the gene would still linger quietly in human DNA, ready to resurface when the conditions align. Today, we're journeying through the winding pathways of evolution, uncovering how the invisible hand of change has shaped not just redheads, but humanity itself. Red hair owes its unique shade to the MC1R gene, which dictates the production of pheomelanin, the pigment responsible for those striking red tresses. But here's the twist. This gene does more than dictate hair color. It's pleiotropic, meaning it impacts multiple traits. For instance, redheads often experience heightened sensitivity to certain types of pain, like heat pain, but are strangely less affected by others. They also require about 20% more anesthesia during surgery, yet often need fewer painkillers afterward. Scientists are still piecing together the puzzle, but these quirks likely stem from the interplay of MC1R and the nervous system. To be clear, this isn't evolution specifically adapting to modern medicine. Anesthesia has only been around since the mid-1800s, far too recent to leave a mark on our genetic makeup. Rather, these traits are incidental byproducts of MC1R's primary role in pigment production. And while redheads' sensitive eye to sunlight and their tendency to burn more easily might seem like a disadvantage, this trait likely played a key role in their ancestors' survival. When early humans migrated out of Africa to northern regions like Europe, sunlight was scarce and darker skin couldn't synthesize enough vitamin D. Over countless generations, lighter skin, which absorbs UV light more effectively, became a survival advantage. This adaptation is why redheads and other light-skinned populations are more prevalent in regions with limited sunlight. But vitamin D isn't the only example of human adaptation. As sunlight waned in northern climates, another challenge arose. Dietary sources of vitamin D became crucial. Enter milk. Ancient Europeans began relying on animal milk as a substitute, despite initial lactose intolerance causing widespread discomfort. Over generations, however, natural selection favored those who could digest lactose, leading to the prevalence of lactose tolerance in many northern populations today. In contrast, regions like Southern Africa, China, and South America faced entirely different evolutionary pressures. One of the most lethal threats in these areas came from an unlikely source: the mosquito. These tiny insects, carriers of malaria, have been responsible for more human deaths throughout history than any other creature. Even today, malaria remains a leading cause of death in many parts of the world, with an estimated 247 million cases annually. Faced with this relentless killer, populations in malaria-prone regions developed a remarkable genetic defense, the sickle cell trait. This mutation alters the shape of red blood cells, making them less hospitable to malaria parasites. While this adaptation significantly reduces the severity of malaria infections, it comes with its own risks, including anemia and other complications. It's a stark reminder that evolution, though ingenious, often operates through trade-offs. Evolution's tapestry doesn't weave perfection, it crafts survival. Lighter skin may fend off rickets in low-sunlight regions, but raises the risk of sunburn and skin cancer. The sickle cell trait may thwart malaria, but increases vulnerability to other health issues. Every adaptation carries its price. Yet these changes underscore humanity's incredible ability to endure and adapt. Today, as we marvel at the intricacies of evolution, we're reminded that this process is ongoing, constantly shaping us in ways we might not immediately notice. Our ability to change, to alter our behavior, our environment, and even our mindset is a legacy of this evolutionary drive. So, what lesson can we draw from nature's resilience? Life is dynamic, ever-changing, and full of challenges that might seem insurmountable. But just as nature shifts and adapts to solve its problems, so can we. When faced with obstacles, perhaps the solution isn't to force the same approach, but to look for subtle shifts, new perspectives, altered methods, or fresh ideas that can turn the tide. As you step into the rest of your day, take a moment to reflect on the moving parts of your own life. Where are the opportunities for growth hidden? What small adjustments could yield big results? And, above all, remember that evolution teaches us the power of persistence, adaptation, and ingenuity. Let nature inspire you to embrace change and evolve toward your greatest potential.